Quiz 406. So I actually do have a video from last year. But every year we learn, we grow, and I did the same things last year that I did this year. So I want to make a new one for you guys. And if you want to watch it, you can. You'll see where I stare and I think. And one of the reasons I do that, and I'm not like a super overly prepared, like I have all the answers type of teacher, is because I think that's really important for you guys to see. One of the things I hated in college and in high school was when I'd go to my teachers for help and they would just be like, well, it's so obvious. And then just be like, well, can't you see? And I'm like, okay. And then in college, if you ever try to ask a teacher, like a math teacher, for help in another course, they'll say things like, well, you should go to that instructor. That's beyond the scope of my course. It happens more often than you think because they become experts in that specific type of math. So anyway, all right, so let's get back into this. That was a little bit, I just thought it was humorous, and you guys are awesome. I love working with you, and I had a student stay after class to finish solving the problems on this quiz. And even last year, we had help lab. So when I made the video, I remember solving it with students in the help lab. Now it's kind of coming back, but that's all right. The problem solving process is the important part. It's okay to struggle. It's okay to not know. I'm not embarrassed. The one thing that will make me sad is when I'm not prepared for you, right? There's a difference between struggling and being prepared. So let's talk about some of the skills that we need here. One of the big ideas for our Unit 4 is formulas. Formulas till we are blue in our face. Formulas. The geometric sequences and series are part of nature. They model different things. So take some time to look them up, research them. Geometric series in nature, the golden ratio in nature, Fibonacci sequence. What are those? And just kind of see the interesting places that they show up. Math, again, is a language that we created to talk about what we see in the world around us. Ooh, I bet even this spirals the different, each row, I bet it has a sequence, a ratio that we could model with what we're learning. Okay, anyway. So we have some formulas, which I'm going to pull this up. Boop. We have our geometric series formula. Series is the sum. So that's going to add them all up. So when they ask for the sum, you want to use the series. Sequences is the list, right? So it'd be like if we asked, what is the total number of loops? We would use the sum. If we asked how many loops are in this spiral, this circle, the belly, that would be the sequence. So it's kind of the difference between the formulas. And then the common ratio is always going to be a further term divided by the previous term. So we don't use the first term as the numerator, as the top, down here. Ooh. Right? The common ratio. We'll use any other term. We can pick any one, the second, the third, the fourth term. That's fine. So if we pick the second term, n would be 2. We would divide it by n minus 2, so 2 minus 1, the first term. Does that kind of make sense? Right, hopefully it does. If not, it's okay. Let's see if the examples make sense. But we're just going to take a term in front, divide it by the previous term, the directly previous term, right next to it. If you flip-flop it and say you take the first term divided by the second term, that's all right. You're just going to see, you're going to get a different type of geometric series because one might be growing and one might be shrinking depending on the ratio. That's why order does matter with ratios. If you remember way back to 6th grade, order matters in ratio. The number of boys to girls will be a different ratio than the number of girls to boys because the order flipped. So order matters in ratios. Okay, cool. This is the basics. That's everything we need as far as formulas. Then we just need our problem solving hat. It's Cat and Hat Day for National Reading Month. It's a hat or stripes or both. So here we go. So what is the sum of the first 8 terms of the series? So I have this in a calculator. I like Desmos. I've already been working in it, as you can see, exploring, trying things, working through things, and we'll talk about those different strategies here shortly, but let's just delete these till we get up to the formula. Okay, so here's the formula. What it says is we need to know the first term times parentheses 1 minus the ratio, which we'll discover, raised to the power of n, all of that divided by 1 minus the ratio. That is the formula for the sum of a geometric series. First, we need to find our ratio. Well, r is going to be equal to any term divided by a previous term. So not the first term, because we need the numerator to be further along. So let's just do negative 200 divided by negative 800. Cool. Let's try it with 50. So if we picked negative 50, we divide it by the previous term, negative 200. Same thing. Let's try negative 12 and a half divided by negative 50. Aha, they're all the same. And that's a key thing in a geometric sequence is the common ratio will be the same for between every two consecutive terms, meaning back to back, okay? Okay, so now that we have our common ratio, which is 0.25, or if we wanted, it could be also 1/4, right? They're the same. Boop, boop, they're the same. We now know our common ratio. We need to find our first term. Well, our first term is literally that. It's literally just our first term. So negative 800. The whole thing. Yep, the negative. Yes, the negative. Okay. Next, we need to figure out what n is. Well, n is where we're going. What does it say? It's, well, here, even in our formula, it'll even directly tell you. Boop. The first n terms. All right, let's go read our problem. The sum of the first 8 terms. Aha, 8. In that case, it's 8. We're going to leave it in. Okay, so I'm going to copy paste this. We now have all of the information we need. We're going to go ahead and start plugging and chugging. I like Desmos because it holds the format and I can type it in nicely. So we're going to do negative 800. I just replaced it. I'm going to use 0.25 because I don't have to worry about like a fraction. Then we're going to do 8 because it says 8. And then again, that was 0.25. You could have used a fraction, that's fine. Aha. So the answer is negative 1066.650391. Ooh. Aha. Round the answer to 2 decimal places, or the hundredth place, right? Tenths, hundredths. We round by looking at the number to the right. If it's 4 or less, let it rest. Thank you for that in class. If it's 5 or more, raise the score. So 43210, we just leave it alone. Let it rest. It ends with that 6.65. If that was 5 or more, 5, 6, 7, 8, or 9, we'd raise the score, so we would round that up to 66. Okay, so we're gonna look at that. We're gonna write that whole amount in with the negative in our answer. Oh, well, wait, look, you get to find it. You can find it. Wow, okay. So then here they're really just kind of checking your rounding skills. Some students get confused. I still get confused. It doesn't really matter. What matters is you figure it out and you try your best, right? Figure out how to round. Look it up. Review it. Ask a friend. Ask a teacher. Okay? Rounding and truncating are skills that you'll use in your life around you. And if you forget how or forget, what's going on, just go find out. That's perfect. That's the more important skill right there. Finding out how you're supposed to round. Okay, so what is the sum of the first 7 terms of the series? Cool, same thing. I'm going to go back to my calculator. They want the sum of the first 7 terms. So let's do it. N is 7. They told me that in my problem. Type it in. Let me type it from scratch for you guys so you can see it. Okay, so they want the first 7 terms, but this is the formula. So let me put in. Okay, there. So typing it from scratch. The first term is negative 8. So I just type negative 8. And then I'm going to type parentheses 1 minus, I need the common ratio. Whoops, I didn't find the common ratio. That's fine. I'm just going to do 16, the second term, divided by negative 8, the previous term. In this case, it's the first term. Okay, my common ratio is negative 2. Cool. I'm going to use parentheses here to keep that negative in with that ratio. Okay, there's the parentheses. Now, according to this, I need to raise it to the nth. So shift 6, or that caret, gets me my exponent. type a 7. That's all in the top. That's the top, so I'm going to come out, click out of it, and then I'm going to click the backslash. Haha, it makes a fraction. Don't worry about this minus, that's fine. The calculator knows what it's doing, it's okay. Now on the bottom, I'm going to type 1 minus parentheses again. The parentheses are important because it's keeping the negative with the common ratio. Ta-da! So according to this, the sum of the first 7 terms in this series with the first term of -8, there's the -8, and a common ratio of -2, it's important to keep it all together, will be -344. Cool. You will have different numbers for your variation. You might have this exact variation. Try typing and following along. If you use a different calculator or this calculator, you just need to be careful with those parentheses, okay? So for the numerator, I'm going to start with a parenthesis. I'm going to type -8. Then I'm going to add the parenthesis 1 minus another parenthesis, -2, close parenthesis again, right? Raised to the 7th power, close parenthesis, because now that's my whole numerator contained in a group. I'm telling this calculator what to do. So I've got to code it correctly. Divided by parenthesis, the whole numerator, or denominator, the whole bottom, which is 1 minus parenthesis, -2, close parenthesis. Okay, we should still get the same thing. So you just have to be careful with your calculator work. Identify each piece for the formula, and you'll be good to go. Question 3, 4, and 5. All right, we're getting into the problem solving area. I'm going to show you 2 ways. I'm going to show you the simple way first. And again, thank you to students who are working with me. One of my favorite things about math and outside of school, it's highly collaborative. Highly. You'll be working with all different ages, all different experience levels, and you'll be trying your best to complete whatever it is you're being asked to complete. Okay? What is the sum of the series? Cool. So we have 3, 12, 48, 192 to 4,009, 49,152. Okay, is that all they tell us? What? Yep, that's all they tell us. Okay, so let's talk about it. We have a formula. The sum to the nth term is equal to the first term, 1 minus r raised to the power of n, divided by 1 minus r. Cool. So we need to see, what do we know? We know the first term is 3. A sub 1 is the first term. We write a 3. Boop. 1 minus r is going to be the ratio, so we'll take 12 divided by 3. That's 4. Raised to the n, which is, dot, dot, dot. All over 1 minus 4. Oh no, we're stuck. We don't know what n is. I'm going to show you a simple way to try to figure it out. It could take a long time, and then I'll show you the algebraic way, okay? So if we first, let me go back to the formulas just to kind of show you again. Formulas. But that's how we found this pattern, and the formulas are beautiful. To find the nth term, you would just do the first term times r, the common ratio, raised to the n minus 1, or repeatedly multiply by r. Does that make sense? It's a common ratio, so every prior term is multiplied by it however many times until we get to that location in the sequence. Think about that. So over here we have 3. What is the common ratio? We already said it was 4, so 3 times 4 is 12. Well, 3 times 4 times 4 is 48. 3 times 4 times 4 is 192. So if you notice, we have our first term, a sub 1, 1, 2, 3, 4, 1, 2, 3, 4, a sub 4. That's how we find a sub 4. So we can just keep doing this in our calculator until we see how many times it takes us to get to 49,152, or what term it is. Okay, so again, I want to leave that writing up. I'm going to use Desmos. Okay, so here we have our first term is 3 times 4, there's our second term, times 4, there's our third term. See, it's changing over here. Times 4, fourth term, right? First term, second term, third term, fourth term. First term times 4 times 4 times 4 times 4. So let's keep going. See if that makes sense. Okay. 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 Oh, wait a minute. That's too big. Aha. So this is kind of the simple way, the brute force, bootstrap way of trying to figure out what term that last number is. 3 is the first one, second, third, fourth, fifth, sixth, seventh, eighth. So according to this, 49,152 will be our eighth term in this series or sequence. So once we have that, now we have everything we need. We just write 8 and we plug this in our calculator. Okay. I'll use Desmos again just to leave the board work up. Okay, so we'll have 3 times 1 minus 4 raised to the 8th, close parenthesis. Oh, whatever, that's fine. Just get it over here so it's a C. That's fine. All those parentheses are fine. 1 minus 4. So according to this, the sum of the first 8 terms in that series is going to be 65,535. Cool. All right, so now let's talk about the algebraic method. Bear with me. We were given the first term and we can figure out the common ratio of 4. We're given the a sub nth term, the last term, but we don't know what n is. But that's okay because we have that formula that says a sub 1 times r to the n minus 1 is this term. We can just substitute what we know and solve for what we don't. That's the power of algebra. Once you set up a relationship, if you're looking for some information, you can solve for it. In almost every case, that's the kind of point of these skills, is so that you're able to take information with the world around you from measurements. Sometimes you're measuring things, and then find the information you need. So the first term, a sub 1 is 3, times r, which is 4, raised to the n minus 1. We're looking for that n. Now we just start solving. This is 3 times 4 to the n minus 1, so the first thing I want to do is divide both sides by 3 because I'm trying to get what I want to know by itself. That cancels, and then that becomes 49, make sure you type it, 49,152. I'm just using my calculator over here. You can use a calculator on the computer or on the phone. 16,384 is equal 4 to the n minus 1. Okay, now what? A couple of things here you could think about. Rules of exponents are what's going to come into play in order to solve for n. Or, yeah, we're going to do it this way. I don't want to do it the other way. So I want to get 4n by itself. Like, how can I do that? There's an n minus 1. Yes, but we have rules of exponents that state a to the b times a to the c is the same thing as a to the b plus c. So using this rule and being clever with how we know math works, we can do that same thing here. But only I can say that 4, working backwards, to the n plus negative 1, right? Because adding a negative is the same thing as subtracting. What? I know. That's cheating. I know. Will be the same as 4 to the n times 4 to the negative 1. That's an n. And then rules of exponents say that that negative 1 is just like 4 to the n over 4. That negative just means we put it into the denominator, right? Or we flip it. If a negative in the denominator, it would go up to the numerator. So we just kind of flip where it is, like the location. review if you want to review, use the brute force method if you want, but I just want to show you both so you have both. Rules of exponents now, lots of prior knowledge, okay? So after rules of exponents, we're going to have that 4 to the n divided by 4. Well, I'm going to multiply both sides by 4. So this becomes that, but I'm going to multiply this by 4, and I'm going to multiply this by 4. Okay, times 4. It's already in my calculator. So over here, we'll get 65,536 is equal to, those cancel, 4 to the n. Now another prior knowledge skill, logarithms. Logarithms are used to undo exponentials. So that's a lot for this one little question. It's a lot when we are focusing on sequences and series and patterns and how they work and how they grow. Okay, so for arithmetic, you have addition, subtraction, multiplication, division. For geometric, you have exponents, which exponents are repeated multiplication, but in order to undo exponents, we kind of need to think about how do exponents work, rules of exponents, and then we need to think about logarithms because logarithms are the inverse of exponents. So lots and lots in this one question. And thank you to classmates for asking this because it really highlighted that skill that you guys would need, right, to solve this. Sometimes a formula isn't enough. We need the problem solving, the thinking about it, not just solving the problems. All right. So take a look at this. You can back it up if you need to. I'm going to get rid of it and rewrite this on the board just for now because we're almost done. 65,536, and then we have a fun problem to solve. And I'm so happy because in class, she suggested maybe we should draw a diagram. Yes. Oh, great. Love that. And then the other one was like, maybe we're thinking about the problem wrong. Yep, I was thinking about the problem wrong. And that's why I love support from you guys. Because remember, I have like the practice with the formulas and whatnot. But when it comes to a word problem or a real world problem, I don't solve it any differently than you guys do. I have to think about it. What do I know? What do I not know? What is the situation? What's happening in the situation? What tools do I have? And then I have to go forward from there. And usually drawing it is really important. Reading the problem is really important. So I'm a bad math student. I've shared that with you before. So don't be like me. Be better. Read and think. Use your tools and see what you come up with. Because often you guys are going to have better and more creative solutions than I will. Okay. Logarithms. So now we have this log base 4. There is a change of base formula, but we want to take the log base 4 of both sides. Boop, 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 boop. The reason is the log base 4 of 4, it becomes 1 and it brings the n down in front. So we're undoing that exponent so we can solve for n, which is our whole goal. Then this is just calculator work. However, you need to do the Desmos graphing calculator because their scientific doesn't have the base. So you need to go into here, functions, log base A, so log base 4 of the 65,536. 8. It's the 8th term, but hopefully you already knew that. Hopefully you realized, hey, that is the 8th term because we did that example where we found it just by doing the iteration over and over and over and over and over again to figure out where 49,500 and something would show up. It would show up in the 8th term. That's the algebraic way to figure out what n is. Once you know what n is, we just plug it in like we already did. We already solved this in this right here, right? We plugged in n is 8. This was just the algebraic way to solve it. So now what if we don't have it? So what if we had to use it on this calculator? I should show you the skill because Desmos is embedded and this calculator doesn't have log base. It doesn't have it. It doesn't have the logarithm. So let me see. Log. See, it won't let me do like log base 4 of 4. Right? It'll say the calculator doesn't support specifying the base of a natural. Try log or log natural. So How do we do that? Well, we're going to do, it's the log of what we were looking for, 6, 5, right? 5, 3, 6 divided by the log of 4. So it's pretty simple. That's what we call the change of base formula. So that's for calculators that don't let you specify a specific base. You take the regular log of whatever it was you were going to do the log base 4 of. Then you divide it by the log of the base you wanted. And we still get 8. Okay, cool. So that's in your toolbox. You have all that in your toolbox. We got to keep going because we've got a bouncing ball to track down. We'll first do this one. Okay, we're going to use this calculator for now just to show you guys another way to use calculators because that's an important ability to use different calculators and check our work. Come on, let me zoom out. Okay, so we have a bike rental company and it is renting out 6 bikes in its first month. The number of bikes it rented tripled each month. What is the total number of bikes the company rented out for the first 6 months? Okay, so what we need to use the formula directly is we need to know our first term. Do they tell us our initial amount? First, six bikes in the first month. Okay, 6. Cool, I'm gonna type that. Parentheses, because the numerator, 6. Well, times 1 minus r to the n, do we know the common ratio? Like, how are they changing? They don't give me any numbers. They don't tell me anything. What am I supposed to do? Well, it does tell you, again, this is where that reading, being a better math student than Mrs. Reynolds, the number of bikes it rented tripled each month. Tripled, what does it mean to triple? Triple, triple, triple. We are, each time we tripling, we're multiplying by 3. The common ratio is 3. They're changing by 3. We'll zoom in. Okay. What is the total number of bikes? The sum that the company rented for the first 6 months. Aha. Well, we need to raise that to 6. Close parenthesis, because that's the formula. A sub 1 times 1 minus r to the n. All of that divided by 1 minus r. That's how you type it in this one. Okay. So that story problem gives you all of the information you need to figure out how many bikes you rented in total. That's great. That's really great. Yes, you could list them, right? And then add them up, but that was a lot faster when you're comfortable for your business in the future. If you want to make predictions, make calculations, it's really good to use these skills that you guys have, okay? But if not, you can always brute force it, bootstrap it, do it by hand. Pedro. All right, we're going to talk about Pedro. Each one of these is going to be a little bit different. So we need to draw this diagram. Thank you so much for that collaboration and good work. Okay. Pedro drops a ball from a height of 4 feet. After each bounce, the peak height of the ball is half the peak height of the previous height. How far does the ball travel from the time Pedro drops the ball until it reaches its peak height after the bounce? 7.5. Let's talk about that 7.5. I wanted to highlight that on purpose. Okay, let's go back up. I'm going to find our formula so you guys can see it again. Control copy. Down to the bottom, Control V. Cool, that's our formula, right? We need to find our initial amount. Boom. 4 feet is our initial amount. Our common ratio, it says it drops by half the peak each height. Okay, so 1/2. And they want to know how far does the ball travel, or the sum of the distances, after the 4th bounce. And again, 1/2. What a minute. Ooh, I think I have another way to think about this. Let's see if it works. But anyway, 7.5. But that's not the answer. It's not highlighted. See, it's not the answer. So I checked my calculator work. I worked with the student. I was like, I don't know what's going on. So we had to talk about it, and she suggested let's draw a diagram. So we're going to do that. I want to try something else really quick. Let's try this. What happens if we do the 5th bounce? Nope, doesn't work. Yeah, see, it doesn't work. 3rd bounce? No. Yeah, okay, so we have to draw the diagram because right now the formula doesn't tell us everything we want to know. So let's do it. All right, what is happening in this situation? So sometimes the equation isn't going to be the best way to solve things. Pedro is dropping a ball from a height of 4 feet. Boop, 4 feet. After each bounce, the peak height of the ball is half the peak height of the previous. Okay, so 4, we're going to go up to 2 feet. But look, we have 2 feet here and back down 2 feet. Then we have half of that, 1, 1. Then we have half of that, 1/2, 1/2, right, up and down. Then we have 1/4 and 1/4. So the distance traveled, let's see, reaches the peak after the 4th bounce. So 1 bounce, 2 bounce, 3 bounce, 4 bounce, we stop right there. So you'll need to add up all of those heights. So 4 plus 2 plus 2 plus 1 plus 1 plus 1/2 plus 1/2 plus 1/4. Okay, add those up because that's the total distance the ball travels. And in this case, the geometric series doesn't tell us everything we need to know. I believe in you. Draw your picture, figure out what's going on, draw the picture, label each bounce, add them up, and you can do it, okay? Draw your picture. All right, you got this. I'll see you guys in class.